Okay, hello everyone, how are you all? So I'm launching the technical polls. Just respond to the polls whether my voice is clearly audible to you or not, and also my screen is visible clearly or not. Just respond to that poll. Everything is clear? Shall I start the class? Yes? Okay, I hope everything is okay. So I'm ending the poll, guys. Okay, so I have ended everything. So we are going to start now. Let me record. Okay. So guys, today we are going to start our new chapter. Okay, and it's a very interesting topic also. That name is complex number. Okay, so in first class, what we'll do, we'll try to understand the basic things of complex number, everything. Okay, and also in perspective of JEE mains or any competitive examinations also, this chapter is important. Okay, sometimes two or one, at least one questions will come from this topic, but many times two questions are also asked in JEE mains also from this topic. So that's why my suggestion is, okay, everyone please go through all the classes in details, and after your class try to solve a lot of questions on this topic. Okay guys, so let's start our new topic and the interesting one, that is complex number. So in the first session, what we are going to cover actually, we'll understand the introduction to complex numbers. Okay, we'll see the very basic things of complex number. Okay, so let's start. So why we are talking about complex number? If anyhow we have a lot of number systems also, up to real number systems we know actually. Yes or no? So, but why we need this number, complex number? Why do we need this number? Okay. So the thing is, suppose you have a quadratic equations like this, x squared plus 1. Okay. If I'll ask you to solve this quadratic equation, so what you will do? How can you solve it? Okay, let's solve this question. Let's solve this quadratic equation first. Okay. So what I'm doing here, I'm solving this one. Okay, so by when I'll try to solve this, I'm getting x square is equal to minus 1. Okay, and what I'm getting, x square is equal to minus 1. Okay, so what what is the value of x here? The x becomes actually plus or minus on root of negative 1. So but we don't know how to find the on root of negative 1. We don't know how to evaluate the square root of some negative number. Is that clear? Till now, we don't know how to evaluate the root of some negative number. So that's why mathematicians, what they did, they discovered an imaginary number, and that is called iota, or we can represent it by I also. So we can say here this is equal to plus or minus iota. So what is this? This is an imaginary number, and this is represented as I, and we can its name is actually iota. Is that clear to everyone, guys? Yes. So here the concept of iota introduced, and that is one imaginary number. Is that clear to everyone, guys? Yes. So if I'll ask you again to find the square root of negative number or negative 1, what is the square root of negative 1? That is actually iota, or I, we can say. Okay, I hope this is clear to everyone. So this is actually the need of a complex number, or this is the need of a an imaginary number. Okay, so let's solve square root of negative 1. What is square root of negative 1? Already we discussed this thing. Square root of negative 1 is I. Remember, square root of negative 1 is I. Okay, so now is it sufficient to is iota is sufficient to solve any quadratic equations? Like here I'm giving you one question, that is x square plus 4 is equal to 0. If I ask you to solve this equation, so what you will do? You don't know. You know, negative on root of negative 1 is iota. But here, when I'm solving it, what I'm getting, that is x square is equal to minus 4 I'm getting here. Is that or not? Yes or no? So x square is equal to minus 1. How? We know actually this negative, on root of negative 1 is iota. But here I'm getting x is equal to plus or minus of on root of minus 4. Is that or not? Yes. So can I say here, this is actually, can I write this as plus or minus of on root of 4 into on root of minus 1? Yes. Can I write this? Yes. So this becomes plus or minus 2 into negative on root of negative 1 is iota. So here I'm getting x is equal to plus or minus 2 iota. Okay. So like this, you can solve the quadratic equations in complex number when you are getting x as some on root of some negative numbers. Is that clear to everyone? Okay. And these are the very basic things in complex number what we are now studying. Is that clear? Okay. So let's move to the next thing, that is power of iota. Okay. So guys, let's see here. Just a minute. Yes. See here, power of iota. If you know that is I is equal to on root of negative 1. Okay. If I'll ask to find I square, what it will be? What is the value of I square? Iota square is. Can you tell me what is the value of I square? That is on root of negative 1 square, that is what? Minus 1. So remember, I is equal to on root of minus 1 and I square becomes minus 1. Yes. So if I'll ask you to find I cube, similarly, what it will be? I cube. What is the value of I cube? Yes, I can write I cube as I square into I. Yes, and we know I square is minus 1 into I. So I cube becomes minus I. Is that clear to everyone? Okay. Similarly, if I'll ask you to find another power of I, that is I to the power 4. I to the power 4. So I to the power 4 can be expressed as also I square into I square. That is minus 1 into minus 1 is equal to 1. So similarly, now I to the power 5. What is the value of I to the power 5? We can write this as I to the power 4 into I. That is I to the power 4 I got, that is 1 into I. So I to the power 5 becomes I. Similarly, I to the power 6 क्या हो जाएगा? I to the power 6 is I to the power 5 into I. So I to the power 6 becomes I to the power 5 is I. Then I to the power 6 becomes I into I, that is I square, that is minus 1. So similarly here, what you are getting, actually we are getting a cycle. First I gives you on root of negative 1, then I square gives you minus 1, then I cube gives you minus I, then I to the power 4 gives you 1, then I to the power 5 gives you, what is that? I. So similarly, if I will ask you to add 4 consecutive power of I, if I'll ask you to find 4 consecutive power of I, then what is the sum you will get? That will be actually 0. Sum of 4 consecutive power of I gives you always 0. See here, you can observe 4 consecutive power. I plus I square plus I to the power 3 plus I to the power 4. Yes. So I is I square is minus 1, I cube is minus I, and I to the power 4 is plus 1. See here, I will be cancelled, minus I cancel out, and minus 1 cancel out. Then what is the sum you are getting? That is 0. Is that clear to everyone, guys? So remember, always remember the sum of 4 consecutive power of iota is 0. Remember, this is important. Okay, so any 4 consecutive power of iota you can take, and if you add them, you will get 0. Any four consecutive power of iota. So simply, if you take I to the power 7 plus I to the power 8 plus I to the power 9 plus I to the power 10, then it gives you 0. Is that clear to everyone? Okay, now I'm asking one question to you all. Okay, so tell me, what is the value of I to the power 99? Clear? I to the power 99. What is the value of I to the power 90? You guys, you can respond in the chat box, everyone. Yes. So I to the power 99 can be written as I to the power 20, but I to the power 96 into I to the power 3. Yes or no? So I to the power 96 is actually, can we write this? Oh, one small thing I forgot to tell you, that is, when you are talking about I power, that means what you should know, when you are getting I to the power some multiple of I to the power some multiples of 4. When you are getting in when in the power of iota there is a multiple of 4, then it gives you 1, always remember. Okay, I to the power 4 is 1. I to the power, similarly, I to the power 4k plus 1. Always remember where k is any natural number also you can check. Okay, I to the power 4k gives you always 1. But if I'll ask you to find I to the power 4k plus 1, then what it will be? That is I to the power 4k. This can be written as I to the power 4k into I. So I to the power 4k is 1. I know that. So then it gives you I. So if I'll ask you to I to the power 4k plus 2, then it gives you I to the power 4k into I square. That is I to the power 4k is 1 and I square is minus 1. Then it gives you minus 1. Okay. Similarly, I to the power 4k plus 3 gives you I to the power 4k into I to the power 3. That is I to the power 4k is 1 and I cube is minus I. Then it gives you minus I. Is that clear to everyone, guys? So remember, when in the power power of iota, if you have a number that is a multiple of 4, then the value will be 1. Simple. Similarly, here you can use that concept. This I to the power 99 can be written as I to the power 96 into I to the power 3. And this is actually I to the power of 96. Is it a multiple of 4? 96, is it multiple of 4? Yes, that is 4. I to the power 4 whole to the power 24. So 24 4 is 96. Then this becomes I cube is minus I, right? So this becomes 1. So 1 into minus I, and this is finally actually what is that? Minus I. So I to the power 99 is minus. Is that clear to everyone, guys? Let me know in the chat box if it is clear to all, guys. Respond, everyone. Yes. Okay. So now you have a question for you. Okay. So for these questions, I'm giving you 1 minute only, and try to solve this question. And your time starts now. Okay. I'm launching the poll also. Just respond to the poll. Which option is the correct one? Anyone got the answer? Please respond in the chat box. Okay, so your time now it's ended. So let's see what is the solution for these questions. It's a very easy questions also. You need to find the value of the sum sigma or summation from n is equal to 1 to 13 of I raised to n plus I raised to n plus 1, where I is the negative of 1. Okay, so try to solve it. Anyone got the answer? Can you please respond in the chat box? Okay, so let's solve this question. Okay, so to solve or to find the value of this summation or this series, so what you will do, just open the sigma. So if you open the sigma, so what you will get? See, summation n is equal to 1 to 13. Can you write this as I to the power n also, plus summation n is equal to 1 to 13 I to the power n plus 1. Okay, now if you put in place of n, or if you open these two sum, okay, so what you will get? So when you will open I to the power n, or when you will put n is equal to 1 up to n is equal to 13 in the first series, that is I raised to n, so what you will get actually? See, when we'll open it, what I will get? That is, I will get I. If you put n is equal to 1, I will get I. If you put n is equal to 2, I will get I square. तो ऐसे कहां तक जाएगा? That will goes towards I to the power 13. Okay. Similarly, similarly, if you open this second series, what you will get? So first we will put n is equal to 1, then I am getting I square. Then if you put n is equal to 2, I am getting I cube plus I to the power 4. Up to कहां तक जाएगा ये? When you will put n is equal to 13, you will get I to the power 40. Right? So we know just before we understand that sum of 4 consecutive power of iota gives you always 0. So by using that concept only, we can solve these questions. So see here in the first series, I to the power 13. So I plus I square plus I cube plus I to the power 4 gives you 0. Again, I to the 5, I to the power 6, I to the power 7, I to the power 8. It gives you 0 again. Then I to the power 9 plus I to the power 10 plus I to the power 11 plus I to the power 12 gives you 0. So one term we are having only in the first series, that is L to the power 13. Okay. So in the second series, in this series, what you are having after adding all those terms, what you are getting? We know the sum of 4 consecutive power of iota is 0. Is that clear to everyone? Similarly, here we can say I square plus I cube plus I to the power 4 plus I to the power 5 gives you 0. Okay. Then start from I to the power 6, I plus I to the power 7 plus I to the power 8 plus I to the power 9 is 0. Then I to the power 10 plus I to the power 11 plus I to the power 12 plus I to the power 13 gives you 0. So only one term also we are having in the second series, that is I to the power 14. So this gives you actually the value, and we know I to the power 13 can be written as I to the power 12 into I, plus, and I to the power 14 can be written as I to the power 12 into I square, right? So I to the power 12 is a multiple of, you know, 12 is actually multiple of 4. Then the value of this becomes 1. So here I am having I plus I to the power 12 is also 1. We know that is plus I square. I square is minus 1. Okay. So what I'm getting actually I minus 1. By simplifying, I'm getting I minus 1. So the value of this series or the sum is actually I minus 1. Is that clear to all, guys? Is that clear to one? Simple? Clear? Just respond in the chat box. Everyone clear about it or not? Clear? Shall I move to the next scene? Okay. Sure. So next thing is now combination of real number and imaginary. Okay. So that is actually, okay, here in your screen you can see there is an equation. What is that? X square plus x plus 1. That is a one quadratic equations you are given. Okay. So if I ask you to find the solution of these quadratic equations, then try to solve it. Okay. So if I solve it, what we are getting, let's see. So by using the discriminant method, we can say x is equal to minus b plus or minus b is minus 1 plus or minus on root of b square. B square is 1 square, 1 minus 4 into 1 into 1, that is minus 4 upon 2 into a, that is 1, 2. Okay, so here we are getting two roots. Okay, one is, that is also simplify or can be written as 1 minus 1 plus or minus on root of minus 3 upon 2, right? Okay, okay. So here I'm getting two root. Okay, one is x is equal to minus 1 plus on root of minus 3 upon 2. Another one is x is equal to minus 1 minus on root of minus 3 upon 2. So it can be written as also minus 1 on root of negative 3 is actually, what is the value of on root of negative 3? That it can be written as minus 1 plus or minus on root of root 3 iota upon 2. And this is also can be written as, also can be written as this. Okay, so here we are getting actually two roots. One is x is equal to minus 1 plus root 3 iota upon 2. Another one is x is equal to minus 1 minus on root of 3 iota upon 2. Is that clear to everyone? Okay, sure. Okay, so this is the root with positive sign and this is the root with negative sign. So two roots you are getting by solving this equation. So one thing I would like to add here, this is actually my cube root of unity, or we'll study this in later classes. Okay, because this these from these portions only questions will be asked in your examinations. So this is simply, this is the quadratic equations and you are solving and you are getting two roots. So when we'll study or when we'll discuss about the cube root of unity, that is so suppose the equation will be x cube is equal x cube plus 1 is equal to 0, then the roots, what are the roots will be. Okay, so in that class we'll discuss about the cube root of unity and there we'll use these roots. Okay, so wait for that. Okay, so let's move to the next thing, that is complex number or the standard form of complex number. Okay, so what is the actually standard form of complex number? So actually basically complex numbers are denoted by the English alphabet, that is Z. Okay, Z, right? So these numbers are denoted by Z and the form of the complex number is actually, what is that? Z is equal to x plus iy, or I'm writing a plus bi. Okay, a plus bi, where a and b are two real numbers. Okay, so remember the form, the standard form of a complex number is this, and it is denoted by Z, and the whole set of complex number can be denoted by also Z. Okay guys, Z or C, capital C. The set of complex number will be denoted by capital C, and the numbers are represented as like this. Z is equal to a plus bi, and where a and b belongs to the set R, or they are two real numbers. Okay, one more thing I'm going to say to you, that is actually a is called here, this a is called my real part. What is this? This is called my real part, and b is called my this part is called imaginary part. Okay, remember complex number can be represented as Z, and this, the form of the complex number is a plus bi, and where the a and b are two complex number real numbers, and a is called the real part and b is called the imaginary part. Okay, okay, now if a becomes 0, what will happen if a becomes 0? If a becomes 0, then Z will be bi. And this actually, when a becomes 0, in this condition, for these two conditions, we can say the complex number is purely imaginary. Okay, so if similarly, the second thing is if b becomes 0, if b becomes 0, then Z is equal to a. right? And this is actually when B becomes 0, the complex number Z is equal to A can be called purely real. Purely real. Okay, guys? When A becomes 0, you are getting a purely imaginary number, and when B becomes 0, you are getting a purely real number. And if A and B becomes both are 0, A is equal to 0 and B becomes also 0, then the complex number will be 0 plus 0 iota. Okay, complex number becomes 0 plus 0 iota. Is that clear to everyone, guys? Yes. Sure. Now, move to the next thing. First, we'll discuss the equality of two complex numbers. Suppose you have two complex numbers. One is Z1, that is x1 plus i1, and Z2, which is x2 plus i by 2. Right? If I'll ask you when we can say these two complex numbers are equal, the condition is when we can say Z1 is equal to Z2. The simple thing is if we are telling Z1 is equal to Z2, that is x1 plus I y1 is equal to x2 plus I y2. That means what I'm saying, if we're talking about the equality of complex numbers, or if we'll equate two complex numbers, then when they can be equal, when we can say both two complex numbers are equal. Yeah. So here we can say that is the condition is if x1 is becomes x2 and x2 sorry x1 is equal to x2 and y1 is equal to y2, then we can say both the complex numbers are equal. Or conversely also we can say if z1 is equal to z2, then by solving these two things we are getting x1 is equal to x2 and y1 is equal to y2, then we can say both the complex numbers are equal. Okay, very simple things. Now we'll go to the next operation, that is addition of two complex numbers. So how we can add two complex numbers? So suppose we are taking the same complex numbers z1 and z2, which is also x1 plus iy1 and x2 plus iy2. If I ask you to find the sum of two complex numbers z1 plus z2, what it will be? How can you add? Similarly, here you can take x1 plus iy1 plus x2 plus iy2. So by adding these two complex numbers, what we are getting, we can separate the real part and also imaginary part. So how we can write this number as also x1 plus x2 plus I into y1 plus i2. Okay, so this is actually this is how we can add two complex numbers. Okay, guys, this is how we can add two complex numbers. Okay, go next. That is subtraction. How can you subtract one complex number from another? Consider same complex numbers z1 and z2. That is x1 plus iy1, x2 plus iy2. Okay, so see z1 minus z2. That is x1 plus iy1 minus x2 plus iy2. Similar way, how you can add two complex numbers in the similar way, you can also subtract one complex number from another complex number. So that is here also we can write this as x1 minus x2 plus I into y1 minus y2. So this is how we can subtract one complex number from another complex number. Okay, so okay, simple thing I'm asking, if I'll ask you 7 a complex number? 7 is a complex number or not? Yes, it is a complex number. How? Sorry, you told me, sir, only the complex number and in the form of a plus bi. No. So this is also in the form of a plus bi. So 7 can be written as also 7 plus 0 iota. Okay, so 7 is also a complex number. Actually, the real number is a subset of complex. Okay, real number is a subset of complex number. Okay, so actually, complex number is the big set. This is set of complex number. This is set of real number. Is that clear to everyone, guys? Yes. So let's we have completed equality of two complex number, addition of two complex numbers, and subtraction of two complex numbers. Now we'll go through the multiplication of two complex numbers. Okay, if you have two complex numbers, same complex numbers I'm considering, then how can you multiply these two? So Z1 into Z. That is simply how we are multiplying in algebra also. Similar way में हमें क्या करना है ना, multiplication भी करना है. That is x1 plus iy1 into x2 plus iy2. So क्या करना है, कुछ नहीं. That is x1 into x2, x1 into x2, then x1 into y2. Plus similarly, if you multiply this 2, I x2 y1, then these two, I square becomes -1, then y1 into y2, minus y1 into y2. So this is how we can multiply two complex numbers. That is also we can write here x1 into x2 minus y1 into y2 plus, if I'll take common I from these two terms, then what I'm having x1 y2 plus x2 y1. Okay, so this is how we can multiply two complex numbers. Okay, so now move through the division of two complex numbers. There are very basic things we are discussing now. Okay, how can you divide one complex number by another complex? Okay, so suppose here we are having these two complex number. I'm asking to find Z1 upon Z. How can you do it? That is x1 plus iy1 upon x2 plus iy2. So the simple process is just rationalize these terms. Rationalize, how can you rationalize? So what is the term you are having in the denominator? Also we can write this as just multiply x2 minus iy2 upon x2 minus iy2. Now we can simplify, or now we can what is the number you will get, that will be a complex number. And when you are dividing Z1 upon Z2, or even dividing Z1 by Z2, you are getting the numerator x1 plus iy1 into x2 minus iy2 upon x2 square minus a plus b into a minus b is a square minus b square. That is x2 square minus I square gives you again -1. So minus will be plus into y2 square. Okay, so this is the rule for division, or this is how we can divide one complex number by another complex number. Clear everyone? So let's solve one question. Okay, now if you have z is equal to 7 plus I upon 3 plus 4i, then you need to find what is the value of z to the power 14. It's very simple. Just use the last concept. So z is equal to 7 plus I upon 3 plus 4i. What you'll do, just rationalize it. You will get multiply 3 minus 4i upon 3 minus 4i. We'll simplify it. 7 plus I into 3 minus 4i, and in the denominator what you are having, 3 square is 9 plus 4 square is 16. That is, here I'm getting 7 into 3 is 21. 7 into 4, 7 4 is 28i minus 28i, and this becomes plus 3 iota, and this becomes I square is -1, minus will be plus, that is 4. Plus 4. Okay, that is upon 25. So simply what you are getting, 21 plus 4 is 25, and this becomes 25i upon 25. Oh, very nice complex number you are getting. That is 25 upon 25 is 1, and 25i upon 25 is -i. So when you are dividing the complex number 7 plus I with 3 plus 4y, I'm getting 1 minus I. So this is your answer. Or we can write this as, oh, this is not your answer. You need to find z to the power 14, right? So z to the power 14. So z I'm getting 1 minus I to the power 14. So it's very simple. How can you do it? So we can write this as 1 minus I square whole to the power 7. So we know how to find 1 minus I square, that is 1 plus I square minus 2I whole to the power 7. And we know 1 plus I square is 0. I square is minus 1. So 1 minus 1 is 0. So here I am having minus 2I to the power 7. That is 2 to the power, what is the answer you are getting? 2 to the power 7 into I. So this will be your answer. 2 to the power 7 into I. This is your answer. That is option C is the correct one. Option C is your correct answer. Is that clear to everyone, guys? Yes? Okay. Sure. Let's move. Now, how we can find square root of a complex number? Okay. How we can find square root of a complex number? It's very simple actually. If you have a complex number like here, I'm giving you one complex number, that is z is equal to x plus iy. Now I'm asking to find the square root of complex number, that is root of z or root of x plus iy. So how you can find actually? Now just suppose we are taking this, let root of x plus iy as a plus ib. Okay. Okay. So I'm taking root of any complex number gives you another complex number. Okay. So I'm just taking or letting root of root of x plus iy is equal to a plus ib. So if I'll ask you to find square both sides. Okay. If I'll square both sides, what you are getting? In the left hand side, I am getting x square. Sorry. I'm getting x plus iy. And in the right hand side, I'm getting a square plus ib whole square. The ib square, I square is minus 1. That becomes a square minus b square. Minus or plus 2ab. I'm getting plus 2ab. So see here, this is the equation I'm getting. If I'll ask you to compare both sides, so here I'm getting x is equal to a square minus b square. By comparing both sides, I'm getting x is equal to a square minus b square, and y I'm getting 2abi. Okay, y I'm getting 2ab. Okay, so by solving these two equations, by solving 1 and 2, you will get the value of a and b. Okay, the value of a and b. You will get a and b. Now, after getting the values of a and b, just put here. And I have already taken root of x plus iy is equal to a plus ib. Now put the values of a and b here, and what is the complex number you will get after putting the values of a and b? That will be the square root of that complex number. Okay, so one homework questions for you. Try to find the square root of the complex number 7 minus 24i, and it's very simple. Also, we can solve within 30 seconds also. Okay, so now it's time to end your class. Till now, what we have completed, guys, we saw, that is how we saw some operations on complex number, and also what is the standard form of complex number, how we can calculate the powers of iota also, and equality of complex number, how we can add two complex number, how we can subtract one complex number from another, how we can divide also, how we can multiply also. So all these things we have covered here, and also finally we learned how to find the square root of a complex number. And I already discussed the method with you. Just try it, these questions on your phone. Okay, so thank you all of you guys. Bye bye. Please take care. So, that's all for today's class.